Lithium-ion batteries are everywhere. You can find them on your smartphone, laptops, and more recently, electric vehicles.
Where do our batteries actually begin their life? So the starting point is actually in synthesis. And being a solid state chemist, our favourite route is called the ceramic but also solid state method. And actually what we do is we take our starting materials and we simply grind them up using a pestle and mortar. We then heat them up to high temperatures, so the powders heat up several times to high temperatures. We then check on the X-ray diffraction, whether it's phase pure. We're now in the advanced materials characterisation facility. And the reason we're here is before we go anywhere near to making our batteries, we need to make sure the powders or samples that we made are phase pure. And one of the ways that we do this is in our inorganic toolbox is X-ray diffraction. And here's one of our diffractometers.
Once we know our material is phase pure, we then have to ball mill it with an additive. To that, we are then ready to start the coating process.
Now needs to be made into an ink so they can be coated onto our current collectors. To do this, we add a solvent and mix until we have a good coating consistency. Too thin and it will go everywhere. Too thick and it won't spread well. You can think of this step like making the icing for a cake. We have to gradually mix water into the icing sugar and make sure it is all well mixed. Once we have mixed the ink multiple times to achieve a good consistency, we are ready to coat it onto our current collector. We draw it down the current collector gently to form a thin layer of coating. We then allow the coating to dry before moving it into a vacuum oven. One of our researchers is now going to show us how to assemble a full coin cell. She has placed one of the electrodes into the coin cell bottom casing, putting the electrolyte and the separator on top, before adding more electrolyte and finally adding the second electrode. The electrolyte helps our lithium ions shuffle between the electrodes, whilst the separator, which looks a little like filter paper you may have seen in your school labs, provides a physical barrier between the electrodes. This prevents the two electrodes from touching directly and causing a short circuit in our batteries, which would render them useless. The final components of the batteries are spacers, a small metal disc and a spring before adding the top casing. We then crimp this together to seal it shut, and voila, we have an assembled coin cell battery.
Once we have made our coin cell, we can then start to test it and see how well it performs. We're not just limited to the little coin cells, we can actually make far larger batteries. You can see here we're coating on a much larger scale. And also Anton has shown the different batteries beyond that coin cell.
First thing I'd probably ask is, so why do we need to recycle these battery packs? Why can't we just send them to landfill?
Well, there's a number of reasons why we need to recycle the battery packs. One is it's environmentally unfriendly and unsafe to send them to landfill. But another key thing is there's valuable raw materials in the battery pack that we can recover and then reuse to remake new battery packs. And so we've got a nice circular economy where our battery pack is used in the vehicle, it's recycled, remanufactured into new materials and then reused in another new material.
With recycling, are there many methods? Is it quite difficult to do?
Well, in recycling a battery pack, there's a number of different parts involved. First, you have to dismantle to give you the individual battery modules and the battery cells. And then they can be either manually dismantled or shredded to get your materials, which you can then apply chemical methods to start recovering all the valuable metals that are inside.
This is our battery safety chamber, which is designed to be able to contain a battery fire. These incredibly thick doors and steel body means that it is the safest place for us to shred batteries. Inside here you can see our wonderful shredder, which is what we use to shred our batteries into small pieces that we can then separate out by physical processes. On this side here we've got a wonderful array of power plugs. We've got these orange gas detectors here, 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 and down there, which is designed to measure the oxygen content and HF content in here. We've also got a building management system here where we can control the extraction in the safety chamber and other aspects of this building.